Hi class, we're going to finish up the temperature experiment to see which is the best growth of for temperature for E. coli. We're going to use the absorbances that we're going to. Hi class, today we're going to do absorbance readings on the E. coli temperature experiment. Okay, so we've grown them for 24 hours at various temperatures, and then today we're going to read them on the absorbance machine or the spectrophotometer. So we're going to go right into that. The machine is calibrated, and then all we have to do is read them. Okay, and so I have a blank here of sample that we use to zero out the machine. It's the media that is used in this sample experiment. Okay, so I'm going to start at 4 degrees, and so we just tip the flask like this, and then it fills with the liquid. And then we're going to go into here, stick it in. And so for this one, we have a negative number, 0, 0, 2, 0 is the 4 degrees Celsius. And then we're going to go to 25 degrees Celsius, actually 22 degrees Celsius. So we pour it in. And then that is going to be 0.004. And then we'll do 30 degrees Celsius. Now you may, if you have a really sharp eye, you may notice that I'm using a different flask. That's because our 30-degree incubator failed. And so we had to re-inoculate a different broth and put it in another incubator at 30 degrees. And so the 30 degree now is 0.686. And then we're going to do the 37 degree incubator. And 37 is 0.855. And then we're going to see 45 degree incubator. And 45 is going to be basically 0, so 0.019. And then I'm going to actually do one more. It's the original culture that was supposed to be at 30 degrees, but it ran at 22 degrees. And we're at 0.171. So it's doing a little bit different than the 22 degrees that we put in there. It looks like the 22 degree sample, the original sample, it may not have been inoculated. It might have been, we might have missed it. It's always that possibility. So we actually, it's a good thing that our incubator went out because we have a redundant supply of data here, so we can take that into account. All right, now we need to just run the calibration curve, graph, and determine the CFUs per milliliter. And then once we do that, we can build a separate graph for each one of these where temperature is on the x-axis and then the absorbance is on the right, or the CFUs per milliliters on the left on the y-axis, and then we can plot out which is the optimum temperature and minimum temperature and the maximum temperature. All right, that's it for today. Ask Christy questions if you have. You can email me if you have questions as well. Thank you. So the temperatures are recorded for their absorbances. They're in this chart at the bottom left corner of the calibration graph. So you can now take the absorbances and figure out the CFUs per milliliter for each temperature. Then you go to another graph which would look something like this, which is kind of a bell curve shape, but it plummets off on the right hand shoulder very steeply, indicating that the samples are not growing very well. And when you plot this one out, temperature versus the CFUs per milliliter, you'll get something like this. And then that tells us that at the higher temperatures, we see not just a slowdown of the growth, but we see a devastating collapse of the growth due to denaturation of the enzymes required to allow the cell to live. And so it is pretty effective showing that. So your job is to create that graph. It should look similar to the one I have here, and put it in whatever report your instructor wants. Thank you.